my following and my background is in teaching fasting for women and how you can use a tool like fasting to balance your hormones. And I've watched everything from somebody getting their metabolic health in order and all of a sudden they get pregnant. I've watched depression and anxiety go away. And I've watched all the hot flashes, the sleep, all of that change. And so I'm wondering if the brain is less sensitive to glucose, is that playing in to this brain function that you're talking about as far as raising temperature and trouble sleeping?
Yeah, 100%. And this may be part of what is happening in the hypothalamus in terms of this kind of glucose insensitivity. And the brain reacts and responds and kind of tries its best to compensate for that. And also, it's not just cells in the brain, it's just neurons in the brain, it's every cell in our body some people, not everyone, can become more kind of insulin resistant and, can't, kind of metabolize and process glucose and make ATP and all of that in the same way. And I'm no expert on cellular metabolism, just kind of makes me want to shut my eyes and have a nap, but that's my TED talk on that. But we see this in every cell in the body, right?
You haven't been
and
up
you'll
late,
be familiar with that.
Yeah, you haven't been up late at night studying the Krebs cycle? I don't understand.
Oh gosh, no, I'm sure there's a textbook around here somewhere with the diagrams. And I think I actually tagged a good diagram the other day that I saw on somewhere on social media. So I should save that to revise, and then I never did. But we see the brain and the cells in the brain react and respond in the same way that cells in the brain do everywhere. We've got, and it's hard to kind of tease out, all of these different body systems because they're all interconnected, and the brains and the nervous system aren't separate from the rest of the body. And we can talk about metabolic health. So we've got neurons in the brain perhaps finding it harder to do the job that they used to, but luckily the brain adapts. If it is healthy, adapts and reacts and responds, and we sort of see this, and I believe some of Lisa Mosconi's work has shown that. I mean, we're in such early stages of imaging menopause in women's brains, but she has shown that adaptation and that response to. And we've got, different people have got different kind of health profiles and genetic profiles and susceptibility, et cetera, underlying that. But the brain does have to work harder, as do other cells in our body when metabolism kind of shifts. I think what we know about the brain as the brain gets older, regardless, sort of menopause aside, if we just look at all humans as we get older, as the brain starts to perhaps struggle metabolically, what it starts to do is it kind of recruits more neurons on board to get the job done. So what may have been quite a specific, well-defined, well-functioning, efficient network that was required perhaps just on one side of the brain to solve a problem. And we can image people doing different types of problem solving, say in the fMRI scanner. The brain will start to recruit more neurons and more networks to get that job done. So the brain's pretty cool in that it goes from having these very well-defined, quite segregated networks. And as you age, we know that sometimes those networks get what we would call more integrated, or they kind of tend to cooperate. And we might go from having one side of the brain doing the job to both, or perhaps more brain activated to get the job done. So, the brain's adapting and reacting and responding in its own way to find kind of workarounds to get the same solution. That process of perimenopause perhaps speeds that process up. It speeds up that kind of, I suppose, I don't want to say it speeds up aging, but it does alter, the brain's metabolism does alter over this point in time. And it's possible that the shifts that we are seeing and that the feelings of part of the feeling of brain fog, and me in particular, because my sleep is pretty well managed, ask my husband, he's just like, I did 10 hours the other night and didn't wake.
Whoa.
Got like a 93 score on my Fitbit. My husband is just like always, he's like the one lying awake every night. I'm like just asleep for 10 hours.
Wow.
But I feel pretty good. But my words, like, man, I'm like, you replacing, I will just say stupid things like, one of the kids walked in the other day with a cap on and I went, "You've got a nice lid." And I was like, "No, I mean hat." Or I will use words that are kind of similarly related semantically, but not quite correct.
Yeah.
Or I'll say, "Oh, well, that's a nice soft apple instead of a nice hard, crunchy apple." I'm like, what?
Right.
Is soft instead of crunchy? Just stupid things.
It's interesting how
that are little
yeah.
word flips. And maybe, we don't know, maybe this is this process of different networks becoming recruited in this sort of change from pre-menopause to post-menopause. That shift may play out in terms of, you know, for me, it's there's kind of like verbal problems or there's verbal recall or sometimes just pulling a complete blank on someone's name. Apparently, and the research shows that lots of women struggle with this during the perimenopause and menopause, and then it kind of recovers, perhaps as the networks react and adjust.
Right.
But of course, to ensure that happens, you want to be doing all the things that you probably talk about all the time, making sure your metabolic health is right, making sure your cardiovascular health is part of that. And people often think about the heart, but the blood vessels, the vascular part of cardiovascular health is so important, because we couldn't do brain imaging studies if we didn't have this massively fine network of brain capillaries of blood vessels in the brain that react and respond to the brain's energy demands, because that's how we do brain imaging. And if your capillaries aren't healthy, we know that capillaries are kind of the first things to go. That's why people with metabolic and, you know, cardiovascular problems, their kidneys go because of the fine vasculature. Their retinas go. Your brain is the same. And so that's why the brain is quite vulnerable as well. Like if you've got super high blood pressure or heart failure or, you know, type 2 diabetes, etc.
Is there a way to increase blood flow to the brain?
Well, by managing your cardiovascular health.
Yeah. So like a workout, like a good workout would be.
Yeah. A workout does, but the brain doesn't just get more blood going to it because the heart is pumping faster.
Okay.
Because those capillaries react and respond to the neural demands. So brain imaging is like fMRI, a lot of those beautiful like kind of rainbow images you see where this part of the brain lights up or that part kind of dulls down, comes about via looking at shifts in blood flow, not necessarily shifts in neural activity. We're kind of looking at a proxy. Okay. And so that process is very, very tightly regulated and managed by the neural activity. It's like saying, hey, we need more blood here. It's not just like make the heart pump faster and push more blood in. It's much more kind of carefully coordinated
Interesting.
than that, which is why we need to take care of it.
Right, exactly.